Morning, everyone. I'm Walter Makakula. I'm based in the Johannesburg office. Okay, I'm based in the Johannesburg office, and I work as a front-end developer in at Vodacom. So today's talk is going to be about the exciting innovations of HTTP and its future directions. So the agenda for this talk, I'm going to start with the overview of HTTP and talk about the evolution, then talk about the future directions. Then I'll open up for questions. Yeah. So starting with the overview, what is HTTP? Okay, so HTTP stands for the Hypertext Transfer Protocol. It operates at the highest layer of the OC model, which is the application layer. So HTTP was designed to transfer information between network devices. So this basically means that it is responsible for the communication between the web servers and the web browsers. It was developed by Tim Berners-Lee, and the first version was released in the early 90s. So yeah, moving to the evolution, I would start with HTTP 0.9. The first version was introduced in 1991. So the methods that were in the first version was like just the get method, and the response was just like plain text HTML. It had there was no headers for the response in the response and in the request. No status codes to indicate any success or errors. Yeah, so it was just a simple protocol. So for the connection establishment, so we have the client and the server. So we had to do a TCP handshake. So the client sends a sync message to the server, and then the server acknowledges and sends a sync message back, and then the client acknowledges. And then from this, and then you can now make the request. So the request looked like this. It was just a method and the resource that you want. And the response was then sent by the server. The response was just plain HTML, which looked like this. And then after that, the connection was closed. So for each and every request, the client needed to make a brand new, a fresh connection. So yeah. Moving to HTTP 1.0, 1.0 was an advancement of the previous version. It was introduced in 1996. So now we have headers in both the request and response. And so this allowed for caching, which improved the response times. And now we have a support for HTTP versioning. So you have to specify the version of the HTTP that you want to use when you communicate with the server when on the like when you make the request. So the added new methods, we have post and head methods. The support for content type, now it does not return just like HTML. You can return like different types of data. So HTTP 0.9 was based on Telnet, and HTTP 1 just evolved to being browser based. So same as HTTP 0.9, you had to do the TCP handshake and then the request, the response, then the connection was closed. But when you do the request, now you have headers and you also specify the HTTP version. With the response, you have status codes, there are headers and the data that you requested. Moving to HTTP 1.1, it was introduced in 1997, and this one had several enhancements and quite a few amazing features. So they added more a cache control. So the header was broken down into multiple directives, which allowed for more control on how the response is cached. And now there's content negotiation for languages, content encodings, and types. So the client can request maybe a French or a Spanish version of the document. New methods were added. We have put, delete, trace, and options. So yeah. So the great thing about this was now we had keep alive or persistent connections. So with persistent or keep alive connections, you basically make multiple requests on the same connection. So this allowed a user to only use only have one TCP handshake and then make multiple requests under that connection. So a lot of time was saved here. So for n request, you have n-1 multiplied by the round trip time of execution time saved. Then another feature that was introduced is request pipelining. So request pipelining, you basically send multiple requests to the server before getting the response. Without request pipelining, you needed to like wait for a response in order to make another request. So this really improved performance. But the problem with request pipelining in this version is that it did not allow multiple response objects to be multiplexed in the same connection. So if you have a delay in the first response, it will block all the response that are behind it. This is causing this thing known as head of line blocking. And then it was later removed from this version because it was causing performance problems. And then another thing was range-based resource request. So with range-based resource request, you basically request a specific part of maybe a response. So you specify the part that you want. You don't like get the whole response. So we have single part and multi-part range. With single part, you just specify like one part that you want. With multi-part, you specify multiple parts with separated by a comma. This was very useful for clients like media players. So this is the connection establishment for HTTP1. It's the TCP handshake, and then you make a request with a couple of headers, and you get a response, which look something like this. And then now you could make another request in the same TCP connection. So moving to HTTP2, this was introduced in 2015, and it was inspired by the SPDY protocol. So SPDY was an experimental protocol developed at Google in 2009 with a goal to improve load times of pages. So the semantics for HTTP methods, status codes, headers are the same in HTTP2 as they were in HTTP1. So HTTP2 introduced this thing called binary framing layer. So it is just a different way of how the message is encapsulated and transported between the client and the server. So we have streams, we have frames now. So streams is a stream is just like a visual channel inside a TCP connection, which has like a bidirectional flow of data. With frames, we have different types of frames, data, headers. Each and every one of them has like a different functionality, and multiplexing was improved in HTTP2 in HTTP2. So now we could be able to multiplex both the request and response. But the problem now is happening at the transport layer. So TCP combines all the requests and response from it combines all the request and response from all the streams in the transport layer. So the head of line blocking is still happening in this layer. Yeah, but it was not that bad because it only it caused a problem in certain scenarios. So another thing that was introduced was HPEG. So before, the headers were just sent as plain text. So now with HPEG is like an compression algorithm. It's used to compress the headers. Basically, you have like a static table and a dynamic table. So the static table is used to store like all the commonly available headers. And then instead of having to use the values, you just use the index of the header that you want to use in the static table. So they are stored in the server and in the client. Another thing introduced was prioritization. So you could assign a weight to a stream, which it basically prioritizes that stream, and you get like the response quicker in that stream. And then we have flow control. Flow control basically the client and the server exchanges like the settings frame, and then they use that frame to communicate that this is the flow control that we want to use. So this basically prevents that maybe having like a faster sender from overwhelming a slower receiver. So we also have server push. So server push basically allows like the server sends resources to the client without the client requesting them. So for example, if you request an indexed HTML, the server knows that you may need the CSS or the JavaScript and with maybe some images, and then it pushes those first and then pushes the indexed HTML file. Yeah. But the problem with server push in HTTP2 is that there was no way to like kind of accept or decline the push, the server push. So this was a problem because sometimes if you cache like some of the resources, the server will still push those resources. So this is how, I don't want to say how streams look like, but it's just like how they work. So you have multiple streams under the same connection, and then we have like a request message is now encapsulated like this. It has frames inside as the response message. You see it has like frames inside. So you could have like any frames, it's settings frames and so on. In stream 2 is just demonstrating that you're making multiple requests and having multiple responses. So with HTTP2, the TCP connection looked like this, which was one round trip, and HTTP2 required TLS. So for TLS, you have 2 round trips to establish the secure connection, and then only after that you'll be able to make a request. Moving to HTTP3 and Quick. Yeah, so this was introduced in 2022. It addresses the problems that we had in HTTP2. So the head of line blocking in the transport layer and the TLS that we have to do when we establish a connection. So that was taking quite a lot of time. So Quick is a transport layer protocol. It has encryption by default. So it has features like authentication, encryption, decryption built in. So now with Quick, you can multiplex at transport layer. So this improved the multiplexing. So now the head of line, the head of line blocking problem is gone. So if one packet is delayed, it only affects one stream. It does not affect the other streams. So another great thing with HTTP3 was connection establishment. So connection establishment has changed now. So Quick basically combines the handshake with the TLS, and it makes all that into like one round trip, which saves quite a lot of time. So they introduced QPAC. QPAC is just an improvement of HPAC. Since UDP runs, since Quick HTTP3 uses UDP, it was just like an improvement to change some features on how it worked. And then server push is also improved here. So the server it's no longer pushing the response objects. Instead, it makes a push promise that a client can either accept or decline. So yeah, that was a great improvement. This is how this is where Quick is. So it's basically between the UDP and HTTP. So it has some features from TCP, and it took that TLS. So this is just for reliability and like other features that TCP provide that UDP cannot provide. Because with UDP, you just send a packet and hope it gets there. So this is how the connection establishment look like. It's just the exchange of the handshake and exchange of the cryptographic keys, and then that's just one round trip, and then after that you could make the request. So this was great with HTTP 3 because now you can after this you can establish you can have a new connection without having to make the handshake or the exchange of the cryptographic keys. So this was great because for new connections it required 0 round trip time. So with the future directions, so there's a growing need to integrate the Internet of Things devices into the web ecosystem. So HTTP needs to improve and adapt into like integrating these devices so that it can be able to manage like the resource constraints and be able to not be overwhelmed by like the many devices that will be connected. So there's also a problem with HTTP2. So backward compatibility is a little problem. So you basically need to have for HTTP3 example, you need to have it in both the client and the server. So it would be great to have like backward compatibility so that like when you add new features, you don't have to like upgrade everything. So maybe new features can be supported maybe in older versions. So the web is evolving each and every day. So HTTP just needs to keep up with the web technologies because they are just improving every day. There are new things, and especially when it comes to security threats, um, there are just always new threats every day. So the improvement in security and yeah, it just needs to be added. Yeah, and that's it. Thanks.